kind of a big integral here, but maybe we can manage it anyway. What do you think for a substitution? We're looking for something whose derivative is in this expression, more or less. Now, this one introduces something a little bit new, because if you look at this piece, if we say u is 2 plus x squared, its derivative is, that just vanishes, its derivative is 0. We get 2x dx. Now that's trouble because we don't have 2x dx over here, but we have awfully close. We have just x dx. We can make this match. It's legal to make tweaks down here. If we want just x dx, we can get rid of that 2, or rather we can move that 2. We can say we'll divide this side by 2, we'll divide this side by 2, and so our modified thing is 1/2 du equals x dx. So if your derivative does not match perfectly, you're allowed to make changes to make it match. In this case, it meant we get an extra factor of 1/2, which is not the end of the world. So now let's see if we can replace all the pieces of this integral. We have integral from, I'm going to write x equals 2, or x equals 0 up to x equals 2, just to remind us that these limits are no good when we're speaking u. I might update them in a minute. We have, this is u squared, so we have 1 over u squared. That takes care of this piece. And then we have x dx, which we can replace with 1/2 du. So I'm going to put the 1/2 all the way outside, and there's du. So that's an improvement for the integral. Instead of 1 over u squared, I'm going to change this to u to the minus 2, because power rule is coming up. Might as well get ready for it. So now if we do this integral, we have 1/2 just sitting outside. Power goes up by 1, so we get u to the minus 1. We divide by the new power. So that's our integral. And now if we're going to evaluate that, you have two choices. You can either take these limits of integration and update them so that they work for u, or you can change the integral back to x and finish it that way. I'll do both. For this first part, I'm going to need to find a new upper bound that works with u and a new lower bound that works with u. The new upper bound would be if x is 2, then we get 2 plus 2 squared, which is 2 plus 4, which is 6. For our lower bound, if x is 0, then u will be 2 plus 0 squared, which is 2 plus 0, which is 2. So where the original integral was from 0 to 2, if you're staying with your u version, then it's integrating from 2 to 6. So how does this turn out? We have a 1/2 parked out front of everything. And then inside that we do plug in 6, so we get minus 6 to the minus 1, which is minus 1/6. Minus, and now we plug in 2 and we get minus 1/2. Fractions. Common denominator for these would be 6, so we get minus 1 over 6. Negative times negative cancels. 1/2 is 3 over 6. Minus 1/6 plus 3/6 is 2/6, so we get 1/2 times 2/6, which is 2/12 or positive 1/6. So that's the answer if we change to u and stay there. If we revert back to x, then from this point, after we've done our antiderivative, we do 1/2 minus and u is 2 plus x squared to the minus 1, and we'd integrate that from 0 to 2. X equals 0 to x equals 2. Does that come out the same? Well, we get a 1/2 here. And we're plugging 2 into this first, so we get minus 2 plus 2 squared to the minus 1 minus, and then we plug 0 into this, and we get minus 2 plus 0 squared to the minus 1. And you can see this is going to come out the same way. We get 1/2. 2 plus 2 squared is 6 to the minus 1 is 1/6. And minus negative, that'll cancel out. 2 plus 0 squared is just 2 to the negative 1 is 1/2. I'm going to skip a couple of steps because you can see this is shaking out the exact same way. So either change to u and stick with it and update your limits of integration to work with u, or switch to u, do your integral, then switch back to x and use the original limits that worked with x. Either way works. I use both of these. It depends on the problem, which one feels easier. In this case, it felt easier to update the limits for u. But if updating the limits is a big nuisance, then I may just switch back to x to get out of it. It depends on the situation, depends on your personal taste a little bit. But you'll get the same answer either way if all goes well.